something new. This is systems of equations, something that I was doing with a student today, and I kind of wanted to bring it to you guys. So what is system of equations? So essentially system of equations is the intersection between two lines, right? That's what we're solving for, the point of intersection. So typically what we've been doing so far is we'll get something like this. I'm going to just draw something horribly, just FYI. And then let's say as well as we get a line like this. And usually we would do these as two separate things, right? You would find the equation of this line. If I was to try to guess, I would say this is y equals, let's see here, 1, 2, 3, 1, 2, 3 halves x plus 3. And then y equals negative x plus 8. Again, not perfect. Obviously, my lines are drawn horrible, but this is what it looks like, right? And essentially, if I was to solve for solutions to one of these equations or both of these equations separately, I'd have an infinite amount, right? That's what a line physically is. It's an infinite amount of answers to an equation, right? Each one of these points is an answer. System of equations, though, is a little bit different. And the reason why is because there's only one possible equation majority of the time. There are instances where there's different amounts. But the main idea is that there's usually one possible answer, and that is at the point of intersection, right? In this case, like right here. Now, graphically, it's pretty simple to solve for. You would do exactly like what I did, right? You would plot the points, or you'd plot the lines. You would look at where they intersect. That would be your answer. It gets a little bit trickier, though, when we are not given a graph. So that's what we're going to be going over today. So that brings us over here. Now, there's two separate ideas of solving these without a graph. It's called solving by substitution, solving by elimination. And today I'll do both. So the first one we're going to do is substitution. What does that mean? Well, the way to do it is actually in the name. What we're going to do is we're going to physically substitute one of the equations into the other equation. So when I say y equals 2x plus 3, that physically means that y and 2x plus 3 are the same thing. So what I'm going to do here is I'm going to rewrite the bottom equation as 3x plus, again, y equals 2x plus 3, right? It's the same exact thing. So plus 2x plus 3 equals 9. There we go. And then from here, what I'm going to do is I'm going to combine like terms and solve. 3x plus 2x is 5x. Okay, so I got 5x plus 3 equals 9. Then I'm going to subtract. I'm going to subtract 3 from both sides. That's going to give me essentially 5x is equal to 6. And now we're going to take it home, divide by 5, divide by 5. X is equal to 6/5. Okay, now that's my x side of this equation. How do I find the y? Remember, the answer is the point of intersection, so it's an ordered pair, which means I need an x and a y value. Well, in order for me to find the y value, I'm just going to plug this in for x, right? X is 6/5. So I'm going to come back over here. Now y is equal to 2x plus 3. I'm going to substitute the x with 6/5. So 2 times 6/5 plus 3. Now, multiply out. Y is equal to 12/5 plus 3. And then what I can do here is I need a common denominator. So I'm going to rewrite 3 as a number with a denominator of 12. So 3. So I need to multiply by 5. So that's going to give me 15/5. 12 plus 15 ends up being 27, so 27/5. So my answer then in this case for this one would be 6/5, comma, 27/5, right? Essentially my point of intersection. Now, next one we're going to do, let me just delete everything here, is going to be similar, except this one we're given a little bit of a different question. And And the reason why it's a little bit different is because notice that this one, y was isolated, right? This thing was set equal to y. That makes substitution easy. Now, a lot of instances, it's going to be in standard form, right? Where we have ax plus by equals c, that type of form. So we have another option. That other option is something called elimination. Now, what elimination is, again, it's in the name. We are going to physically eliminate a variable. So then all we have is one variable, and then we're able to solve that way. So how do we do that? There's a couple ways. In this case, it's kind of set up for me to do it one way, which is we have 3y and negative 3y. So we can add these equations together physically. That is going to essentially eliminate the y values, isolating the x values, and solve it that way. So let's do it like that. Yep. Okay, so 3y plus negative 3y cancels out. 2x plus 4x ends up equaling 6x. And then we got 19 plus 1, which ends up equaling 20. Divided by 6 on both sides. And look at that. X is equal to 26ths. You would think that I would come up with easier questions, so then I wouldn't have to deal with a bunch of fractions, but hey, guess what? I mean, a lot of your guys' homework don't have perfect numbers, so I guess I am stuck struggling with you guys. Okay, so x is equal to 26. So how do I find y? Now, even though this one was substitution, and you would think that substituting, we're also going to substitute here in this case, right? We don't have to eliminate my x value and find the y. We can just substitute just like the other one and find it that way. But in this case now, instead of having our y value, I think this is what we solved for. No, we still had x. So we're still just going to plug it in for x. Same thing, right? So which one do I plug it into? It doesn't matter. I like the fact that this has a 1 smaller, so I'm probably going to do it over here. So first things first is, what is 4 times 20 over 6? So 4 times 20 over 6. Well, I can cross reduce. That's going to give me 2. That's going to give me 3. So in other words, it's going to be 40 thirds. So I have 40 thirds minus 3y equals 1. Now here comes the fun part. I'm going to subtract 40 thirds from both sides. So that's going to give me 3y is equal to, and I'm just going to do this all in one step. I need to subtract, right? Which means I need a common denominator again. So this is going to be 3 thirds minus 40 thirds. And then that's going to give me negative 3y is equal to negative 37 thirds. Jeez. And then finally, we're going to divide on both sides by negative 3. Dividing is the same thing as multiplying by the fraction. So this is the same thing as multiplying times 1/3, negative. And that's going to give me y is equal to negative 37 ninths. So the answer is going to be x is equal to 20 over 6. Y is equal to negative 37 ninths. Whew. Okay, let's keep it moving. So more questions here. We're on to the third one now. Let me just delete everything. Okay, this 1/3 might be a little stubborn. Okay, oh, well, awkward. Unfortunate. Okay, next one. X plus 2y equals 7, 3x minus y equals 4. So it doesn't necessarily have to be perfect for us to use one or the other, right? This comes at your discretion, right? Which one should we use, substitution or elimination? In this case, I'm just going to go substitution, elimination, substitution, elimination. If it was me, I would probably use elimination in this case. The reason why is because notice that in this case specifically, I can multiply the bottom by negative 2. Actually, I'm just going to do that here. In this case, what I would do, which is what I'm going to do, is I'm going to multiply this whole thing by 2. And the reason why I want to multiply it by 2 is because when I rewrite this is going to give me x plus 2y equals 7. Notice how the bottom is going to end up being 6x minus 2y equals 8. Now, why is that important? Because now I can cancel. So I'm going to do the same exact thing. I'm going to add these up. That's going to give me 7x is equal to 15. And look at that, it's another fraction. X is going to equal 15 sevenths. Okay. Now, same thing, I'm going to plug it back in. This time I'm going to plug it back into the top one. The reason why is because I don't have to multiply it by anything. It's just x by itself. So I'm going to have 15/7. Let me just write this over here. 15/7 plus 2y is equal to 7. I'm going to subtract by 15/7 on both sides. That's going to give me 2y is equal to 49/7. Again, I'm already just finding a common denominator here because I need it to be 7. So I multiply the top and bottom by 7 minus 15/7. That gives me 2y is equal to 49 minus 15 is 34/7. And then I'm going to divide by 2. Again, that's the same thing as multiplying by 1/2, giving me y is equal to 34/14. Which again, we can reduce to, let's divide it by 2, 15/17. So the answer there is going to be 15/7, 17/7. Okay. I am worn out. So let's bring it home, right? This is the last one here. So let's see what we got. Let me just delete this. I'm sick and tired of these now. I'm fighting for my life out here. Okay. Final one. Now, this one I'm going to solve by substitution again. I would, again, probably solve this one using elimination, but just to show, I use substitution, which is going to be probably the worst question yet. So which one should I isolate? Now, again, I would highly recommend elimination here, but if we're going to use substitution, I'm probably going to isolate this y up top. So what does that mean? Well, I'm going to subtract the 5x to both sides, and then I'm going to divide by 2. That's going to give me y is equal to negative 5/2 x plus 4. Now, yes, if you're thinking it, you're right. That means I have to plug this value in here. So that's going to give me 3x minus 4 times. I'm getting lazy now, so I'm just going to physically just drag this here. This, okay, is equal to negative 2. Okay. Now, I can cross-reduce the 4 and the 2 here, which is going to make this 3x minus negative 10x. Okay, I reduced this because now this is a 2 and this is whatever. Same thing here. I'm going to, actually, yep, I'm going to reduce this here, which is going to give me 4. Well, I actually can't, so I'm going to multiply out. That's going to give me minus 16 is equal to negative 2. Okay. Now, I kind of got tripped up there and thought I could reduce. I totally forgot that this isn't a fraction. The only reason why I can reduce here is because what I would do technically if I wasn't going to reduce is 4 times negative 5, which would give me that negative 20 value, and then divide that by 2, which would end up giving me 10 anyway, so I just reduced it up front. This I can't do that with because there is no fraction, so I simply have to multiply out. Now, 3 minus negative 10 is the same thing as 3 plus 10, right? Double negative. That's like the same thing as do not turn right. So you mean turn right. Same thing here. Not taking away means just like giving me something, right? So in other words, this is 3x plus 10x. That gives me 13x minus 16 is equal to negative 2, which means that 13x is equal to 14. Again, adding 16 to both sides, dividing by 13, x is equal to 14/3. Lord have mercy on me. So let's finish it. What do I have to do? I have to plug this in. So which one am I going to plug it into? I'm going to plug it into the top one. Why not? I don't think there's really any difference here. Okay, so 5 times 14/13, sorry. Okay, 5 times 10 is 50. 5 times 4 is 20. So this ends up equaling 70. So 70 thirteenths plus 2y is equal to 8. Okay, I subtract 70 thirteenths to the other side. So that gives me 2y is equal to, okay, 8 times 13. 8 times 10 is 80. 8 times 3 is 24. So that gives me 104. So 104 thirteenths minus 70 thirteenths is going to give me 2y is equal to 34 thirteenths. Divide by 2. And you get y is equal to 34 26ths.